So number 9 says, consider the equation 2x minus 4y equals negative 10, and what is the slope of that line? Well, we did a problem earlier where we had to solve an equation for y, and if I was to solve this for y, I'd more than likely end up getting this equation in slope-intercept form. So that's what I'm going to do. I'm going to begin by taking away 2x from each side, so this equation will become negative 4y would equal negative 2x and then minus 10. Again, I have equal things. I took away 2x from each side. I took away equal things, so I get equal things. Now I'm going to multiply both sides of this by, I'm going to push through the factor of negative 1/4 this time. Negative 1/4. When I do that over on the left-hand side, I end up getting just plain old y, right? Negative 1/4 times negative 4 is y. On the right-hand side, I end up getting a negative 2 over negative 4, which is positive 1/2 x, and then negative 10 times negative 1/4 would be negative 10 over negative 4, so positive 10/4, which is the same as 5/2. All right, 5/2. So this is this equation in slope-intercept form. It has a slope pattern of up 1 over 2, and it has a y-intercept at 5/2. So what is the slope of this line? The slope of this line is 1/2. And on many of your tests, you're just inclined to throw that x there. The x is the variable. It's just telling you how many times you go up and then over, up and then over. You don't include the x with the slope. The slope is just up 1 over 2. That's the slope. Now the next question says, what is the slope of a line that's perpendicular to this line? And I want to just visualize this real quickly. We've seen this before, but here's a line, and you can see there's a slope triangle on it. Let me zoom in a bit. And what happens is I'm going to take this line and I'm going to ask GeoGebra to rotate the entire line 90 degrees about the origin. Now there could be some other point where I want to do this, but I'm just going to do it about the origin. But the thing is, when I go through 90 degrees, right, I want you to notice, first of all, these two lines are really indeed perpendicular to each other. I can demonstrate that in GeoGebra by asking GeoGebra to measure the angle. In fact, let me do that. So if I measure this angle, boom, boom, into wrong direction. Let me see, I can't do that. There it is. It's 90 degrees. And you can see I can take that angle and I can ask it to, oops, not you, rotate it back. And you can see it goes back and it's not 90 degrees, but it comes back. And I rotate it through 90 degrees. Now, the thing that I want us to focus on is when I go through this rotation of 90 degrees, whoops, hello. What we see here is before the rotation, right, this original line has a slope pattern of up 1 unit and then over 1, 2, 3, or up 1 over 3, or 1/3. The other line, if I look at it, this has a slope pattern where I go down 3 units, right, down 3, and then 1 to the right. So this has a slope pattern of negative 3 over 1. So, or we could just call this negative 3, right? That's the slope. So notice what happens when we go through this rotation and we end up with lines that are perpendicular to each other. The slope triangles end up switching places, right? What was my rise becomes the run. And what was the run, here it was 3 units, becomes the rise, which is negative 3 units over here. The other thing is that when you go through 90 degrees, you're always going to get the slopes to change sign. So one of them's positive and one's negative. And you can see this one's the one that's increasing, it's going up, and this one's sloping downward as we move from left to right. So since we know from part A that the slope of this line was 1/2, right, the slope of a line that was perpendicular to it would have to be opposite in sign. So it was positive, so this is now going to be negative, and it would have to be the reciprocal. So you could either write negative 2 over 1 or just negative 2, and that's the slope. Notice again, there is no variable x in there. The slope is just down 2 over 1, and then down 2 over 1, etc.